Welcome to Learning with Philemon. In the previous video, we looked at some of the physical properties of alkali metals. In this video, we will look at the typical chemical reactions of alkali metals and how their reactivity changes down the group. As discussed in the previous video, alkali metals are soft and can easily be cut by a knife. When you do this, you notice that the interior of the alkali metal is shinier than the exterior. However, this shiny surface also quickly becomes dull. This is because alkali metals react with oxygen in the air. A general word equation to describe this reaction is metal plus oxygen yields a metal oxide. A specific example of an alkali metal is lithium plus oxygen forms lithium oxide. Pause the video and try to write a chemical equation for this word equation. I would recommend that you watch the ionic bonding video in order to get the correct formula for lithium oxide. The chemical equation for this reaction would be the following. The reason the interior part of the alkali metal is shiny is because it is the pure metal. Let's say for this example, pure lithium. However, once that surface is exposed to air, the lithium reacts with oxygen, forming lithium oxide. Lithium oxide has a white color, which dulls the shiny appearance. A word used to describe a metal's color becoming dull when exposed to air is tarnish. Because alkali metals react quickly with oxygen, they are stored in oil in labs. Alkali metals lower in the group, such as potassium, react faster with oxygen and therefore tarnish faster. We will discuss why the reactivity is different later in the video. Now let's take a look at another reaction. Alkali metals also react vigorously with water. When alkali metals react with water, they form a metal hydroxide and hydrogen gas. Potassium, for example, reacts with water to form potassium hydroxide, or KOH. As stated before, alkali metals lower in the group are more reactive. The reaction between alkali metals and water becomes faster and more violent. In this video, we will see potassium reacting with water. The first thing that happens is a ball is formed that moves quickly along the surface. The vapor produced is hydrogen gas. This reaction is exothermic, which means it produces heat. This heat is enough to ignite the hydrogen and little pieces of potassium inside, forming a lilac flame. The potassium hydroxide produced is basic, which is the opposite of an acid. If you add universal indicator to the aqueous solution formed, it will turn blue or purple, showing that the pH is greater than 7. Now let's have a look at why some alkali metals are more reactive than others. When metals react, they lose electrons, so they have a complete valence shell. As a result, they form positive ions or cations. Here we can see both lithium and potassium losing one electron. Remember that the protons in the nucleus have a positive charge. Therefore, there is an electrostatic force of attraction between the nucleus and the valence electrons that are negatively charged. As you go further down the group, the atoms have more electrons and therefore there are more shells filled. This increases the distance between the nucleus and the valence electrons. The greater this distance, the weaker the electrostatic force of attraction. As a result, it is easier for an electron to leave the atom. For this reason, potassium loses its electron more easily than lithium. There is an increase in reactivity down the group. This means that francium, Fr, is the most reactive alkali metal, and lithium, Li, is the least reactive alkali metal. To practice these concepts, check out the worksheets on my Patreon page. If you want to support my channel, check the donation link in the description. If you haven't already, please subscribe to my channel to get notifications for new videos. Stay curious.